Hey, this is Dr. B, and it's once again time to answer those questions. We received a question on the discussion board saying, how do we enter those Lewis dot structures? So I have taken the liberty of finding the Module 3 assignment. I've blown it up for you a little bit here, and I'm going to go ahead and do just one of them. You'll still have to do the rest on your own. Now be warned, 90% of this answer is going to be formatting, so you can avoid this altogether if you just write it with a pencil and take a picture, things like that. But I want to give a nice, in case you want it to look pretty, I'm going to show you all the gory details for how I would answer this question. So let's go ahead and do it. So we have, there it is, we already have box ready to answer it in the what we call the template that you have. So I think I'll just center this about, and I am going to make it centered, and I'm going to make it huge. We need one zinc and we need one chlorine. So I'm going to put plenty of space in between, and then I'm going to just make this massive because I'm going to put lots of dots around it. So I'm going to make it much bigger. There it is, maybe even bigger. Now I need a bunch of dots, so I think I'll make little shapes that I'll call my electrons. And let's just take one. Oh, that came out pretty good. There it is. We got a nice little dot there. Now zinc is +1 because chlorides are always -1. That means this has one valence electron that it's going to donate to chlorine to form an ionic bond. Chlorine has 7 valence electrons. Look those up on your periodic table. You'll see them listed at the top, and therefore it wants one more to become isoelectronic with a noble gas, and it will take that zinc electron and it will form a very strong electrostatic ionic bond. That means chlorine will need its 7 valence electrons. So I'm going to take this, copy it, and paste it, but then I'm going to format that shape and change it from blue to red because want it to be pretty like that, and I need 7 of those. So I'll copy it. There's 1. I need 6 more. 1, 2, 3, 4, 5, 6. And I think I've got all the valence electrons I need. And I'll take that one that zinc had, I'll put it a little closer to chlorine to try to emphasize that it formed an ionic bond, transferred it over, and there it is there. Now I need the 3 lone pairs, which are a pain to line up, but I'll try to I'm not going to worry about it being perfect, but there's 2, there's 4, and these little alignment guys are very helpful. And there's 2 lone pairs, and then I need 1 more, and oh, I think that's good there. Let's see how that looks. Yeah, I think you can see that this is +1 and -1. If you wanted to go even further, just briefly, you could throw in a separate text box that says +1 and -1 to make sure that everybody knows that we've got ourselves an ionic, not a covalent bond here. You could write it above just for your personal notes, really, is what these are. These aren't required in the answer, but it looks very similar if it was covalently bonded, which it's not. So I'm going to do it like that. And that is an indication of where the electrons are in zinc 1 chloride. I won't show each one of these, but for here I think you better draw a carbon and 4 hydrogens. You probably need to insert them separately. You can't just type them in, since I would spread them out around that. And then I would draw the valence electrons for carbon and hydrogen, and 2 different colors would be nice. Show them there. For nitrogen triiodide, 1 nitrogen, and then an iodide, and an iodide. And I would draw those, consider whether these need formal charges or not, and you can get through them like that. I hope that this helps you in drawing and figuring out your Lewis, also known as electron dot structures, for Module 3 assignment questions 9 through about 12.